Hi, I'm Oni, and I'm part of two IIT alumni who post daily videos on math and physics on our YouTube channel, Mathophy. Let's get started with our JEE problem. Okay, so today we'll be starting with electromagnetic waves. The first question is the RMS value of the electric field of the light coming from the sun is 720 Newton per Coulomb. The average total energy density of the electromagnetic wave is. Now over here we know the ERMS. The ERMS is given as 720 Newton per Coulomb. I'm ignoring the unit for now. It won't make much difference because they are all in SI units. Now the formula which most students confuse is they put that the energy density is equal to half epsilon naught E square. Now this is incorrect because this only gives you the energy density of the electric field. In an electromagnetic wave, there are two energies, one because of the electric field, another because of the magnetic field. The magnetic field energy is given by half of B square by mu naught. This, if you calculate, if you put the value of B naught and so on, you will see that it would be exactly the same as this. So when you combine the two energies, the total energy density is just half epsilon naught E square plus half epsilon naught E square. That is just epsilon naught E square. These E's are all RMS C's. So we know what our answer is going to be. Let's put the values in. 8.85 into 10 to the power minus 12 into 720 square. Now in a competitive examination, you don't need to calculate it in detail. You can roughly go 7 square is 49. So 720 should be somewhere around 50. So this would be somewhere close to 50. Multiplied with 8.85, I can approximate that this is equal to 9. 9 into 10 to the power minus 12. And this would be giving me into 10 to the power minus 12. And 720 square approximation would give me near about 50 into 10 to the power 4. So now if you just multiply 9 into 50, you can see it would go somewhere around 45. So there's only one option that matches this. So the correct option is option number 2. This is how you skip through the calculations using approximations. Let's move on to the next question. So this question is from Huygens principle. It says that 2 points are situated at the same distance from a light source but in opposite directions. The phase difference between the light waves from the 2 points will be one of these 4 options. Now this is a very trivial question if you know the concept well, that if you have a light source, which I'm assuming in this case is a point source, then it emits light in both directions, and a wavefront or a phase difference change only means how many waves have been traversed. So if the medium is same on both sides of the light source, that means if the light source is supposed at the boundary of two medium, this is N1 and N2, if the medium is the same, if both are N1, then how much phase difference will be on each side only depends on the distance. Since it has been said here that the medium is the same and it moves the same distance, hence we can conclude that their phases will be equal, and the difference in their phases, that is the phase difference, will obviously be 0. Let's move ahead to our next question. In this question it says that a beam of monochromatic blue light of wavelength 4200 Armstrong in air travels in water which has a refractive index of n equal to 4 by 3. Its wavelength in water is going to be. Now we know because of a different refractive index, the velocity of light when moving from one medium to the other shifts. It decreases in value. It decreases by a quantity v is equal to c by n. Now if it is decreasing by this, now one of the two things have to change. Either, since we know that v is equal to f lambda, so either f has to change or lambda has to change. So this is the property that you should know, that the frequency does not change when moving from one medium to the other. It's the lambda that changes to accommodate for this change here. So if v is becoming 1 by n, therefore the new lambda should also become 1 by n times of the original lambda. So the lambda value decreases and hence the velocity value decreases. So in our problem, let's put the values in. Our original lambda is 4200 Armstrong divided by our n value is 4 by 3. If you cut with 4 here, it goes with 1, 0, 5, 0, 3 into 1050 is going to be 3100 and 50 Armstrong. So correct option is option number 3. So today we did some electromagnetic waves, a bit of Huygens principle. Next day we'll be moving to wave optics, where we'll be doing with interference mostly, and then eventually diffraction, polarization and so on. So stick around for that video. I'll see you again the next day.
Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.